Hello, and welcome to Extract the Facts. My name is Mauricio Villegas, Business Development Manager at Koch Modular Process Systems. I have the pleasure of speaking to my friend and colleague, Stan Lam, today around the topic of carbon capture within the chemical processing industry. Stan, welcome.
Yes, thank you, Mauricio.
Stan, I've worked with you for the last couple of years, but maybe it would be helpful if you could introduce yourself to the audience.
Yeah, sure. Yes. Yes. Again, my name is Stan Lam. I grew up in Hong Kong, but I went to college in the UK. I started working in a mass transfer operation company. By mass transfer, I'm sure you know, it's distillation, absorption, or liquid extraction, and that has been my career for 40 years. And somehow, CO2 removal seems to be a major part of my career. As you know, CO2 is an undesirable product in a lot of processes. Say in natural gas, CO2 reduces the heat value of natural gas, so it has to be removed. In the fertilizer process, you have to make ammonia to make fertilizer. And to make ammonia, you have to make hydrogen syngas. And CO2 is a byproduct of hydrogen syngas production. And it has to be removed because together with carbon monoxide, it poisons the catalyst in the process. And also, for power plants, CO2 is a major greenhouse component in the atmosphere. If we allow the CO2 to be vented to the atmosphere, by definition, CO2 as a greenhouse gas traps the heat from the sun in the atmosphere, and it warms up our Earth, and hence the term global warming. So it has to be removed to reduce global warming. Okay. But the power industry is still in its early stage of carbon capture. There's a lot of work still to be done in this area.
Great, Stan. That's really interesting, and I appreciate you sharing, the 40 years plus of background. And can you possibly share some of the benefits, for example, process design, execution, or whatnot, that carbon capture has offered to specific companies you've worked with in the past?
When I first started working on CO2 removal, it was mainly for, like I said before, ammonia syngas or natural gas. Okay, and the technology was most commonly a solvent-based technology. Okay, using amines or potassium carbonate. Okay, but in the past 10 to 15 years, a lot of work has been done, for power plant carbon capture. Okay, people are thinking about using membrane to remove the CO2, and some people are actually using a direct air CO2 removal process. Just like pulling CO2 from the air. Right. So a lot of work has been done. Only that the solvent-based technology is still the most commonly used in the industry. Okay, there are only a couple of commercial scale carbon capture plants in this world, and they're all solvent-based. Over the past 40 years, I've seen a lot of changes in the carbon capture technology. Okay, when I first started, typically it takes about 2 tons of steam to capture 1 ton of carbon dioxide. Okay, and if the units are small, that would not matter so much. But for power plants, the scales are much larger. So it just needs to be more efficient than that. So over the past 10 to 15 years, the solvent technology has improved. And I think that number has been cut into half. So we're talking about 1 ton of steam to capture 1 ton of carbon dioxide. And that is quite impressive. But still, the energy consumption still accounts for about 20 to 25% of the power plant output. That's very substantial. Okay, no power plants would like to see their power output reduced by 20 to 25%. It's just too much. So as process engineers, we have to look into processes to reduce that power consumption, and we call that parasitic power consumption, because it's not producing anything; it's just consuming, the output from a power plant.
Great, Stan. Thank you. I had a question for you. How have you seen, things change from, carbon capture from a power plant perspective to traditional carbon capture? What would you see the major differences being?
Yeah, that's a very good question. In traditional CO2 removal from like process syngas or natural gas, usually oxygen doesn't come into play. Okay, but for power plant flue gas, there's always some oxygen in the flue gas, and oxygen presents a problem for solvents. Um, it causes the solvent to degrade, it to break down. Okay, so it's an undesirable component, but then it is there. So as engineers, we have to put in additives in the solvent to slow down the process of oxidation. Okay, and also, it won't stop all the oxidation, but it will slow it down only. We also have to use reclaimers, to remove the degradation products and therefore to purify the solvent. Okay, and that's number one. Number two is also a big factor. Compared to syngas or natural gas, power plant flue gas is at a much lower pressure. Okay, as we all know, high pressure is good for absorption, low pressure the opposite. Okay, so flue gas being at a lower pressure requires a higher circulation rate of solvent. And the more solvent you use, the more energy we have to use to regenerate the solvent. Okay, so energy consumption is a big issue for
So is
power
that what
plant.
brings us to that 20% differential that you were talking about, the parasitic?
Exactly, yes. So that's the most important factor for power plants. Okay, um, a lot of the solvents have been used, invented in the past, and we have built, pilot plants for customers to test different solvents. Usually when you build a plant, it's tailor made for certain solvent. Okay, but we have to be inventive and make the design more flexible, so the pilot plant can be used for different solvents.
And Stan, in those situations, how early do clients approach you and start working with you on development?
Wow, sometimes those projects take years to develop to develop. Okay, and sometimes they're fast. Okay, there was one customer a few years ago. They had a concept. They went to somebody else. Okay, to build the pilot plant, and they realized, no, this is not the people we want. So they came to us, and now we had to make up for the lost time. All right, so we built that unit for them in a very, very fast time. Just a few months. We have to
Would that be like a
do it from.
demonstration? Yeah.
Yes. So we built up small pilot plant for them, and then the next project, when they have a larger unit to build, they also came to us. And we'll go into details later. Yeah, that was an ammonia-based solvent.
Great.
Okay. Mm-hmm.
Do you have any examples of maybe very high level, if you can walk us through a particular project where a client came to us and from beginning to end?
Yes, yes, we can pick up from where we left. Yeah, ammonia. Yeah, that customer, they had a process, but they had never, built an actual plan to run the process. They had the idea of using chilled ammonia to absorb CO2. Um, so they came to us. So we helped them build a unit. Uh, so the conceptual idea was made, you know, um, uh, into a reality. Okay, um, ammonia and CO2, they react to form ammonium carbonate, and when the concentration is high, it forms solids. So it presents a unique problem because we usually deal with liquid and gas, but now we have solids to deal with in the process. So, in the piping design and in the temperature control, we we had to be very, very careful. Okay, it's a very specialized project. We were not allowed to use any 90-degree elbows. Any turn, any elbows had to be 45 degrees in some areas. Okay, and the temperature couldn't be too low because then too much solids would form. Okay, and also the temperature cannot be too high either because it becomes corrosive. It is things like that we help the customer to build and put the concept into a reality.
I mean, you mentioned that you have 40 plus years experience. So on projects like that, what do you feel like you bring to those projects? Because it seems to be like a lot of consideration that need to happen.
Yes, what we do best at Koch is mass transfer. Okay, we specialize in the technology inside fractionation columns. Okay, like distillation columns. So together with the advanced mass transfer products from Koch, we put together the best package for mass transfer. Okay, a customer might have a very good solvent, but if the CO2 absorber or the regenerator is not well designed, you're just losing the advantage of the solvent. Okay, so to help the customer maximize the efficiency of their solvents, we we just use the most up-to-date mass transfer devices and the technology. Okay, so they'll gain an edge over their competitors.
I see.
Mm-hmm.
Great, that's excellent. Thank you.
Sure, sure.
Anything else that you wanted to add about the benefits of carbon capture in a power plant environment versus traditional?
Um, well, at this stage, most of the projects we do, um, they are for large-scale pilot plants. Okay, when it comes to commercial units, those columns are very, very, very big. Yeah, we're talking about 40-foot to 50-foot diameter columns. Okay, it's not something we are capable of handling. Uh, our best fit would be the modular units. Okay, mainly large scale pilot plants for them to first prove their technology before scaling up. Okay, and we specialize in modular construction. All right, as you know, there are a lot of advantages in modular construction. Right, um, all the modules are built off-site. Okay, so site interference is minimal. Okay, and also the quality is better if we build the modules inside shops, right? I'm sure you know the advantages of modular construction.
Right. So if you mentioned that our sweet spot is the development of pilot scale, demonstration scale, and then once it goes to commercial, it's outside the size range of a modular system. How does that transition typically work with between us at that phase handing over to whomever is going to be building the large commercial scale?
Okay, Yeah, we most likely will do the engineering.
Mhm.
Okay, we'll do the um, the front end engineering. Okay, and then we will hand over to a large contractor. Okay, like Sargent and Lundy. Okay, and they will be, responsible for building the large equipment, like the large columns. Okay. That,
Understand.
yeah, that's how we have worked with them.
Great. Thank you. As far as trends going forward, where do you see trends in this space going?
I think there will be a lot of carbon capture activities. Okay, I don't know if you've been reading the news about this COP26. Is a climate change summit. Okay, and it had just been concluded in Glasgow, in Scotland. Okay, uh, about 200 countries with about 25,000 people attended that conference. Okay, at the end of the conference, they agreed they have to do something about the weather. Okay, or climate. Right?
Right.
They have to reduce the CO2 emissions. Okay, and by 2030, it needs to be reduced by 45% of the 2010 level. Okay, so that's a lot of CO2 to capture. So in the past, in the next 9 years, all right. So it's only 9 years away. There will be a lot of frantic movements in capturing carbon dioxide.
Without sharing any confidential information or client names, are you in the process of working on early studies in this space right now?
Well, we are not only doing that, we are also in the process of building another large-scale pilot plant for a customer. Yeah. So we're very active in CO2 capture.
And you only see that increasing from what I can see.
Yes. Yeah, as you know, I keep saying this, the energy efficiency of carbon capture is very important. And that will be the trend in the next few years, or maybe next couple of decades, right? The current energy consumption is just way too high. The status quo is just not good enough. We just need some breakthrough. As process engineers, we have to be better. We have to, reduce the energy consumption in capturing CO2.
A lot of things that we've been hearing about lately is decarbonization and electrification of projects. So I think this fits in with that as well. So I think it's a great initiative, going forward. Anything else that you want to share with our viewers before we close?
Yes, sure. I would say one more thing. We are not tied to any solvent supplier. We are independent of the technologies in the market. Okay, so we can build carbon capture units using solvent, or we can use a membrane unit, or we can use any other technologies. Okay, we will just pick the best technology for a particular situation.
Mhm.
So the customer is not tied to one technology that we associated with.
I think that's important.
Okay.
Being technology agnostic is a very, very good point to make. Thank you.
All right, sure. Yeah.
Stan, thank you for sharing your insight on carbon capture and sharing your 40 plus experience with us. If anyone does have any questions for Stan, please feel free to contact us at kochmodular.com. And thank you for watching Extract the Facts, and please join us next time. Thank you. Take care.